Hi guys, this is Miss Holtz. Let's take some time to talk about how we can find acceleration from position data. So when we were doing the coffee filter lab, or the lab you will be doing, you're going to get some position time data from your tracker analysis. But essentially, we want to find force, the drag force. So we know that forces cause accelerations. So we need to find an acceleration in order to determine the drag force on the coffee filters. But we can't really see acceleration. We need to calculate it based on information about velocity of an object over time. But even then, we can't really determine an object's velocity unless we know something about its position over time, which is the data that we're starting with. So what exactly are these relationships? Well, we know that velocity is the same thing as a change in position. That's the delta symbol, it means change, over a change in time. We could write that more succinctly as v equals change in position. In our case, we're going to have a y position. Displacement is a vector, so I'm going to put that over that. And velocity is a vector. So we have our change in y position over our change in time. And another way you could write that is velocity equals y2 minus y1. So a change in position across 2 points, and then a change in time would be the same way, t2 minus t1. And this is similar to what you think of when you think of a graph, when you have a position time graph. So here's your time, and here's your position y, and you have some line along it like that. Your slope is your velocity. So when you have 2 points here, this will be your first point at time 1, and your first y position, y1, and this is your time 2 and your y2. So you can think of this point as time 1, comma, y1, and this one is time 2, comma, y2. So you have your change in y over your change in t is your rise over run, or your velocity, change in position over time. So once we're able to calculate our velocities, we're then able to calculate our accelerations. So we know that acceleration is the same thing as a change in velocity over a change in time. And again, we can write this with a little a with a vector symbol, a v with a vector symbol, and t for time. And again, we can take this a step further and write our change in velocity as a second velocity point minus a first velocity point over that second time minus the first time. And it's the same concept as the slope of a position time graph giving you velocity. This is just slope of a velocity time graph giving you acceleration. So once we have acceleration, that can tell us something about force, because forces cause acceleration, and we'll talk about that a little more as we go through this lab. So hopefully that gives you a little bit of an idea of why we need to use our position time data to find acceleration and how we're going to do that.